Significant figures is a very important concept in science. It has to do with reporting the numbers that are measured in the laboratory. So significant figures are totally based on measurements. If we're talking about a number that does not come from a measurement, we don't have to worry about significant figures. So a number that doesn't come from a measurement is, for example, a number by definition, like 100 centimeters in a meter. That's infinitely significant. It's really 100 decimal point 000 out to infinity because it's by definition. If I'm counting, there are 1, 2, 3 books on the table. That's an infinitely significant number. It's not based on a measurement. But data, things that involve something measured in a laboratory, that has to do with significant figures. And it has to do with how good your equipment is. Take a look at these pictures. This is a beaker. You'll notice it only has marking every 10 milliliters, 20, 30, 40, 50, 60, 70, 80. That's a terrible piece of equipment to measure with because you can't measure very exactly with it. And in fact, beakers are not made to measure with. So never measure with a beaker. Erlenmeyer flask. Also terrible to measure with. 50, 75, 100, 125, 150, 175, 200. Terrible markings. This is better though, look. This is a graduated cylinder. This is intended to measure. That long line right there, that's 10 milliliters. And in fact, there's a marking every half a milliliter here. 10, 10.5, 11, 11.5, 12, 12.5, etc. So now we have something we can deal with. So a graduated cylinder is good to measure with. It's another graduated cylinder with different markings. There's a marking every 1 milliliter. This is a burette. It actually reads down. But there is here a marking every 1/10 of a milliliter. That's the best of all. Now when you're writing a number, you want to write down the most significant figures you possibly can. Let's take a look at this one because it's easiest to think about, I think. If I'm looking at a volume in this graduated cylinder, I can read to the milliliter how much solution is in there. I could say it's 75 or 76 or 83 because I can read that. But I can also estimate. I can say, oh, it's somewhere between 84 milliliters and 85 milliliters. I'm going to estimate 84.6 or something like that. Now, I cannot estimate beyond 1 digit. I can't say it's about a quarter up, so I'm going to say it's 81.25 because I can't tell the difference between 0.2 and 0.3. So in practice, significant figures are everything you can measure exactly plus 1 estimated digit. Every time you're in a lab, no matter what kind of glassware you are using to measure, it's always everything you can measure exactly plus 1 estimated digit. You always want the maximum number of significant figures you can possibly have.